Okay, so due to our snow days that we've been having and having to push the test back, not getting as much review in class or time for questions, I'm going to finish the review here in this video so that way you can see a walkthrough of all of the problems here. So if you watched the first video, that's what's already filled out here, so I'm not going to go through that again, but I'm going to go through the ones that I haven't gone through yet. So we're going to start with number 2 up here. To write out the problem, y equals 5 times 2 to the x. So we want to know, is it growth or decay? Remember, if you see a fraction, it's decay. If you see a whole number, it's growth. So this is growth. The y-intercept, you want to set x equal to 0 and solve. So anything to the 0 power is 1. So for the y-intercept, we would have 5 times 1, which is 5, so our y-intercept is 0, 5. Let's look at the asymptote. Remember, that is if we add or subtract anything at the bottom, at the end. So that's the c. And if we don't, it's just 0. Remember, it has to be a line, a horizontal line, so it's y equals 0. The domain is always the same. It's all real numbers. And then the range comes from our asymptote. So you can just take the asymptote directly and just make it y is greater than whatever that asymptote is. Or again, you can write that as 0, comma, infinity. And for all real numbers, you can also write that in infinity form. Now to sketch the graph, remember we can use Desmos. So just go and enter this graph in Desmos and then see what you get. I'm just going to sketch it out briefly here. So there's my intercept. This is going to be my asymptote. And since it is growth, it's going to go up to the right. So it's going to look something like that. Let's look at number 4, right? An exponential equation. So first we want to figure out what our a and our b is in our equation, because remember, the equations are in the form f of x equals a times b to the x plus or minus c. Whenever we are writing an equation from a table, we're not going to have a c though, so you don't have to worry about that. So we really just need to figure out what is a and what is b. So a is whenever x is 0, so that's right here. So our a is 202,500. Our b is the ratio. It's what we're multiplying or dividing by each time. Now this one, there's some pretty big numbers, so it's kind of hard to tell. So you want to take, for example, you could take this number divided by this one, or you could take this one divided by this one. So let's take this number divided by this number, and then I get 1/3. So we are multiplying by 1/3 each time. And then we just plug our numbers into the equation. Okay, for 7 and 8, these ones down here, you have to say if it's exponential or if it's linear, and you have to explain by saying what the pattern is. So to get from 64 to 16, and 16 to 4, and 4 to 1, I am dividing by 4 each time. So this would be exponential because I'm dividing by 4. For number 8, we are adding 6 each time, which means that it is linear because I am adding 6 each time. Let's go on to the word problem. So let's look at number 10. So for these ones, we're going to either use the exponential growth or decay formula or the compound interest formula. You only use compound interest formula when it says it's compounded. So you have to see the word. We can see here number 11. If it says compounded, that's when you use the compound interest formula, and that one we're going to give to you. Now the interest formulas for growth and decay we're not going to give to you, but the only difference is if you're adding or subtracting after the 1. So let's look at number 10. So the population of Smallville in 2003 was 35,000 people with an annual rate of decrease of about 2.4%. So it's important to note that this is decreasing. Here's our starting point, and here's our rate. So our equation is y equals our starting rate our starting number, which is 35,000, times the rate, so 1 minus our 2.4%, remember that has to be in decimal form, to the x. So these formulas you're going to have to memorize. This is our decay one, and the one in number 9 is going to be growth. This came from, I'll go ahead and write it out here. That's our decay one. And this is our growth. So those ones you're going to have to memorize. Okay, now we want to use the equation that we created to estimate the population in 2007. So they gave us the population in 2003, and we want to know the population in 2007. So what is the difference between those? 4. So the 4 is going to be our t, the x, this exponent up here. Now, if you wanted to, you can simplify this inside first before you put it in your calculator. Either way is fine. That simplifies down to 0.976. So you could do that first or after. And when you enter that in your calculator, you should get 31,759 people. I'm going to show you how to enter this real quick, if you don't remember. So we have our 35,000, and then we have parentheses, and you can either put in the 1 minus, or you can put in the simplified version. And then we want 2 to the x. So I press that little A to the B button. And that is our equation. Now our x, we know, now is 4. So I'm going to make that 4, and there's our answer. Okay, let's look at number 11. You deposit $2,200 into an account that pays 3% annual interest. After 15 years, you withdraw the money. What is the balance if the interest is compounded quarterly? So this is our compound interest. So whenever you see the word compounded, remember, we're going to use the compound interest formula. And since that one is going to be on your formula sheet, we're going to be giving that one to you. So I'm going to write that out here. So A equals P, that's our starting amount. Just like in our previous ones, that first number is your starting amount. So that's going to be my 2,200. And then I have 1 plus. Now we have R over N. R is the rate, so that's our 3%. So that's going to be in decimal form, remember. Now, the N is how often it's compounded. Ours is compounded quarterly. Quarterly means 4. 4 times a year, quarter, 4. So that's going to be 4. And then to the N times T. Now we just figured out the N was 4. And now the amount of time. So if we look in our problem, it's after 15 years. So I'm going to put these parentheses in here that you're going to need in your calculator. You have to have all those sets of parentheses or it won't work out. And when you do this, you should get around $3,444.50. Again, I'm going to go ahead and enter this into the calculator for us so we can make sure we are doing this right. Okay, so we have 2,200. And then we have 1 plus, and I need another set of parentheses here. So we're going to have that again, and then we're going to put our 0.03. You have to use the divided sign. On your calculators, you cannot use the little fraction symbol. You have to actually do divided by. And then we're going to close that with 2 sets of parentheses, 2 at the end. And then we're going to take that to the power. Now we need another set of parentheses, 4 times 15. Oops. There we go. 4 times 15, and then close that, and then click enter. As you can see, we get 3,444. Okay, let's look at number 12. In the year 2008, Daniel's print shop purchased a new printer for $35,000. Each year it depreciates at a rate of 5%. So I see the word depreciates. That means lower, going down. So we're going to use our we're going to use the decay formula for this one, because it's going down. So we will have y equals 35,000 is our starting point, 1 minus, because it's depreciating, and then we have our rate, to the x, or to the t, whichever one you want to put. And if we simplify that down, we get 0.95 to the x, if you go ahead and take that 1 minus 0.05. Now, how much will the printer be worth in 2012? They gave us it starting in 2008. So 2012 minus 2008 is 4 years. And so we're going to put 4 in for that number. And when you do that, you should get 28,507.72. Let's look at number 13. You invest $1,600 into a savings account at a rate of 5.75% compounded monthly. So remember, whenever you see the compounded, we're going to use the compound interest formula. Now, compounded monthly tells me that I'm going to be compounding 12 times a year, because it's once every month. How much money will you have at the end of 6 years? So let's write our problem here. A equals, and we're looking at, I'm just going to go ahead and highlight that up here. We're looking at this equation again. P, that's our starting amount. And then we have 1 plus another parenthesis. What's our rate? 0.0575 all over the amount of times that were compounded, which is 12. If you have trouble remembering this part, you can kind of think of that as, so we have the rate, but we have to split that up over the number of times that it's compounded, right? So if our rate is 5.75%, well, that's every month. So we have to divide that by 12 then. And we're going to take that to the power of that time again times the number of years that we're going to be doing this. So that's 6 years. And we should get 2,257.32. Okay, let's go on to number 14. The number of bacteria in a certain culture increases by 10% every hour until available space is depleted. Only 100 bacteria are present to start the growth. So this one's a little bit different. It doesn't deal with money this time. But we're still just going to be using our exponential growth formula. Because it says growth, there's nothing in here about compounding. Growth, and it increases. So we know we're going to be using our growth formula. So we'll have y equals. Now it says that only 100 are present at the start. So y equals 100. That's our starting point. 1 plus, because it's growth. And then we have our rate, 0.10, which is 10% to the x. So this is just writing an equation. When the growth of bacteria space is unlimited, that just means we don't have an x. We don't have a time yet. But now we want to know after 24 hours of growth. So we're going to replace that x with 24. So y equals 100. I'm going to go ahead and simplify that to 1.1 to the 24. And we should get 985 bacteria. Okay, number 15. So mine did not copy over here, so I'm just going to write them out as we go. So we're comparing the graph of each function to f of x equals 3 to the x. So if we have f of x equals 3 to the x minus 5, when we add or subtract anything on the end of it, not in the exponent, that goes up and down. When it's subtracting, we go down. The number of spaces is the number that's there, so we go down 5. For b, f of x equals 3 to the x minus 2, but that minus 2 is now in the exponent, which means we're moving either left or right. Remember, this one's kind of confusing. It's almost like opposite. So it's minus 2, so we're actually going to go to the right 2 spaces. Then we have f of x equals 3 to the x plus 10. Again, it's at the end, so we're going up and down. Because we're adding, we go up 10. Finally, we have f of x equals 3 to the x plus 3 in the exponent. And because we're adding, we're going to go left 3. Okay, we have just a few more. Let's look at number 17. And we are comparing the graph of 6 to the x plus 7 to g of x equals 6 to the x plus 12. Remember, whichever one is at the end is our old one. Whichever one is at the beginning is our new equation. So if we're starting with 6 to the x plus 12, I'm going to sketch a little graph here. That means that we're starting all the way up here at 12. And our new one is at 7. So to get from our starting one to this one, we went down 5 spaces. Remember, you can graph both of these in Desmos on your test, and you can just see how many spaces did it move. All right, let's look at 18. I'm gonna erase this so I have enough room. Number 18, it tells us that the graph of G is a translation of 11 units down. And we're starting at f of x equals 5 to the x. And it tells us we're going down 11. So that means we're going to have to change it at the very end. And so we're going to put minus 11 at the end. So we would go down 11. Okay, so that is it for the review. Make sure you have all of this done and filled out. If you have any questions, please email me and I'll get back to you as soon as possible to help you the best that I can.